So in this video, we're going to talk about the physical side of networking. So we're going to talk about these network devices and how they're physically constructed. So what is a network device? You know, these load balancers and switches and routers, what are they really? Well, these devices are physical appliances. You know, they're things that are used to, forward packets or do some sort of processing on packets. There's some sort of entity used to do that. And in practice, these entities may be physical, but they may also be virtual. So you may go out, you may buy physical routers and switches and interconnect them. Or you can go on services like VMware NSX and Amazon Web Services and things like that and construct virtual appliances and virtual switches. These are different devices that perform different operations on packets, and they may be physical or virtual. So some of the physical devices, they look like this. They're these physical enclosures that have a bunch of holes in them and ports you can plug in cables. So how are these devices physically constructed? Well, to shed some light on this, I'm going to walk you through how a real device is constructed. And I'm going to choose a representative example. Let's go through a Cisco 7604. So this is kind of a typical router. This is a layer 3 switch. And if you look at it, it's kind of like a cube. It's got a physical enclosure and it has a bunch of stuff in front. So let's go through this to kind of understand what it is. So first of all, there's a chassis of the router. The chassis of the router is the physical enclosure of the router. It's a big piece of metal, usually made out of aluminum. It might have some plastic in it, that protects the router. And when you design a chassis, when you choose a chassis, the size is very important. Because you're not just going to take this router and put it on the floor. No, instead you're going to have a wiring closet or a data center. You're going to have racks. And when you buy racks have kind of standard spacing. There's older racks that have kind of wider spacing and things like that. But nowadays when you buy a rack, it's got kind of a standard width. And you're going to buy a router that fits that width. So you're going to buy a chassis that's a certain size. Another thing to keep in mind when you look at the chassis is airflow. So what router designers do, and rack-mounted computers and device designers in general, what they do is when they design the device, they hire mechanical engineers to kind of go in and think about airflow. So there's all these components on circuit boards inside of there, and some of them get hot. And so they think about that. They figure out where to put fans, and then they map out the airflow through the device. And you can see the holes on the sides. That's where the air comes out and goes in, keeps the device ventilated so it doesn't get too hot. And when you stack these up, you want to think about airflow going through the device and where that air goes. Is it going to go out right into another device? You want to keep spacing on its sides for the air to kind of flow around. So thinking about airflow through the device and airflow through your entire data center is important because you want to keep these devices cool so they don't overheat. So that's the chassis. Now, if you look at this device, you can see it's kind of modular. There's kind of these rows inside of it. And what these rows are they're called line cards. You can see little screws on the sides. If you undo those screws, you can actually slide out these line cards and slide them back in. And there's a reason for this. Because if you have a router and it fails, usually a piece of it fails. It's not like the whole router just blows up. So what happens is you have these individual little holes in there, these ports. And if a port fails, what are you going to do? Are you going to take the whole router and ship it back to Cisco and wait 3 weeks for it to be repaired and get it back? Have all your networking offline for your entire building for that amount of time? No, what you can do is you can hot swap these line cards. These line cards are hot swappable modules, so you can kind of slide it out, and if you have a spare, just plug it back in. And there, you only have a few minutes of outage. So if a port is broken, you can swap out the affected line card and replace it without having to replace the entire router. So modularity is really important for router design. And when you run routers, you want to have spares around. You can hot swap them in. So these are line cards. There's other components on the router that are also hot swappable. There's power modules in the back. When you wire up your data center or your networking facility, you can run redundant power in there. This is a good way to do it. Instead of running one power line into your data center and running everything off of that, you want to get two. If you can get it from 2 different power companies, that's great. Or 2 different hubs or co-location facilities. You want to have your power as diverse as possible. So if a lightning strike hits one, or if a power station goes offline, the other one is still lit up. And what you want to do is you want to maintain that redundancy all the way to the physical device itself. And a lot of routers will actually have 2 power units in the back or multiple power units in the back. So you can plug in 2 power cables, so if one fails, the other one can take over. So in the back of this device are some power modules. And those are hot swappable as well. So if a power module fails, you can flip a switch and pull it out and put in a new power module and keep it running. And it'll keep running the whole time if it's plugged into the other power module. So those are redundant as well. There's also these fan modules on the sides. So fans are what kind of push air through the device. And fans can fail. So when those fail, you can hot swap those out. And now there's also these individual ports. So you have a whole bunch of people in your building or a whole bunch of IoT devices and you want to wire them up to the rest of your infrastructure. You're going to run cables from those devices into these individual ports. So these are various sorts of ports. There are Ethernet ports, optical ports, and so on. So we call them ports. We also call them interfaces. These are names for these little holes where you plug in cables. And in the diagram, I'm calling them Ethernet ports and optical ports, but there's actually names for these little connectors. Like in Ethernet, I don't know if you've ever looked at Ethernet cable. It's got that little thing you can kind of push in there and it clicks. A little piece of plastic on the top you can kind of push down and pull it out. The name for that connector is RJ45. And you might have seen that in older phone cables. Like when you kind of connect phone lines to walls like we used to do. Those are RJ11 cables, RJ11 connectors. So that's the name of the little physical connector. All these connectors have names. So when you have a router, you're going to look at the ports and you're going to know what kind of connectors they are. You can look that up. And then you can just make sure you use cables that can plug into those ports. There's optical ports as well. There's also some special ports on here. There's one called the console port. Now the console port is very important because when you buy a new router, you can take it, you can plug it into the wall, and then you can plug in network cables, and then it's not going to do anything because you haven't told it what to do. Sure, it's got routing protocols on it. It's got various sorts of Ethernet protocols and things like that. That's all on there. But you need to tell the device what to do. So when you first buy a device, you need to go through a configuration process where you tell it, okay, you've got these ports, and this is what I want those ports to do. This is going to be a port that's going to run OSPF. You're going to run link state on that port. That's connected to another router. This port over here is connected to a subnet, with this prefix, this mask, and so on. So you need to tell it what ports are connected. You need to tell it what protocols to run. When it gets advertisements, how to disseminate those advertisements. There's a configuration that process that needs to happen in order for these devices to work. And the way you do that is through the console port. So these routers inside, they actually have a little computer inside them. I mean, sure, they have hardware to forward packets and things like that, but the computer is there. It's got a CPU, it's got DRAM and all that stuff. And it's sitting there and it's running routing protocols. But it also has a terminal. And so it'll provide you the ability to connect in a console and get a terminal and get a prompt and a command line. You can actually type in commands to these routers. That's the purpose of the console port. You can also set up these Ethernet ports so you can SSH into the router and connect up to the control plane that way to configure it. But when you first get the device, that hasn't been configured yet. So how do you configure it? The console port. So that console port is a special port. You don't want to just give anyone access to that. Because if they get access to that, that's access to the control of the router. They can do anything in there. So the control port is something you're going to take your laptop and then connect into that. And you can see that control port is a RJ45 connector, but you got to be careful. It's not an Ethernet connector. So one kind of annoying thing that routers do, and there's a reason why they do this, but they use these RJ45 connectors, but they actually run a serial protocol over them. So what you need to get is an RJ45 to serial connector to connect into those. Other routers, you're going to see just a straightforward serial connector, and then you can kind of connect that as well. Computers today don't typically have serial ports, so you can go online and you can buy a RJ45 to USB connector, or a serial port to USB connector to connect it to your laptop, and then you can run Hyperterm or some terminal program to log into it. So you can do things like that. But at the end of the day, what you're going to do is you're going to use the console port to connect into the router and then give it commands to do things. Another thing to note is there are some ports I have labeled SFP here. So one thing that router vendors do is they make things even more modular than line cards. Because if a single port fails, it's kind of annoying to replace the 24 ports on an entire line card. Wouldn't it be great if we could just replace that one port? So there is a standard for that, actually, called SFP. And what SFP is it's a pluggable module where you can actually remove a port and plug it back in. And what it is it's a port, And it's got all the logic on that port, and it can be kind of removed and plugged back in. And so those ports I have labeled there are SFP ports. And you can look at them and you can kind of see, those don't look like Ethernet ports. They're just kind of holes. But what I can do is I can buy an Ethernet SFP and slide it in there. And the great thing about SFPs is they're customizable. So I can buy an Ethernet port and slide it into SFP, and then I could, say later, oh, actually, I wish I had an optical port there. No problem. I slide out that SFP port and slide in an optical port. So you can replace things, and you can deal with failures a lot easier with these SFP ports. Unfortunately, SFP ports are not always compatible across vendors. So if you buy an SFP for a Cisco device, it may or may not be able to plug into an F5 device, and so on. So these are the ports, and these are the cables that connect into these ports. So I'm showing optical cables, and you can see there's kind of 2 cables per connector. Some optical cables just have 1 cable per connector. There's a console port cable. You can see I'm doing RJ45 to serial there. There's some different SFP ports there, and you can see I've got some Ethernet ones and an optical one there in the middle, and there's Ethernet cables there. So when you work with these different cables, there's a few things to be careful of. We'll talk about that in later videos. So when you kind of run cables, you have to be careful of the turn radius. You don't want to bend them too much. For optical cables, just remember there are lasers shooting through those, so you don't want to like point those in your eye. With optical cables, if you ever cut them apart, just remember there's little tiny, very, very tiny shards of glass in there. That's what the optical carrier is. So you got to be careful about like touching that can go in your skin and things like that. But these are kind of the cables that we work with these devices. Another thing is that if you look at this device, you're going to see a lot of lights that light up. There's various status indicators that tell you about the health of the device. When you work with routers, they talk about alarms. So if a port fails, if the router overheats, these are events that occur, and these events trigger alarms. And in the old days, we'd use SNMP, which was kind of a reporting protocol. Nowadays, there's REST APIs that can report this information. But in addition, there's LED indicators. You can kind of walk down your row of routers and kind of look at statuses and look for red lights and things like that.